So welcome back. This is chapter 4, part 2. So we need to continue talking about central tendency. To start with, let's go ahead and start with a review question. So that letter right there, that's Greek letter, is mu. Mu is a parameter. Parameter because it describes the population. Mu is the mean. It's the mean for the whole population. That means it's going to be a parameter. If that was X bar is a statistic. Okie doke. Let's go ahead and talk about some things that you've probably heard about before as well, but we need to make sure that you know them. When we talk about central tendency, the reason why we talk about central tendency is because we're talking about the center of a distribution. Now remember when we talked about histograms? Histograms, if you remember, I actually put a little curve over the histogram to show you that that's where we were going, okay? So skew has to do with whether or not the distribution is being skewed by some small number of scores, either positively or negatively. And so we need to talk about skew and modes. So skew is whether or not there's some that are pulling the average up or down, pulling the mean up or down. Modes means how many bumps do you have? Like how many peaks? If you think about them as like mountains, how many peaks do you have? Okay? So bimodal and unimodal means bimodal means two peaks. Unimodal means one. That's what that means. So let's go ahead and take a look at some of the data that we were looking at previously. So we're going to look at the menudo stuff. If you remember, this is what we were looking at before. These are all the members that have ever existed in menudo, how old they were when they began their time in menudo, how old they were when they ended, and tenure means how long they were there. So we were looking at the tenure. If you remember, the mean was 3.56. Okay, mu equals 3.56. The mean for the whole population is 3.56. The median was 3, and the mode was also 3. The mean, median, and mode were similar, but they weren't quite the same. When we talk about skew, what we're saying is that there's a distribution of scores, and something is skewing that mean a little bit more positive than the median and mode. So this is a skewed distribution. Now the easiest way that you can see this is with a histogram. So let's take a look at the histogram. This is the histogram of the stuff we were looking at before. Okay, this is the histogram of the tenure of people in menudo, right? How many times, how many years they stayed in menudo. So if you see this histogram, you'll see that it's pretty easy if we wanted to create a curve. It would look like that. If we wanted to create a curve over it, it would look like that, essentially. And you'll notice that this is not a symmetrical curve. Okay, so a symmetrical curve would look like, I'm going to try and make it symmetrical, right? Symmetrical. So if you look right down the middle, it would all be the same, right? The middle, there's an equal amount on both sides. I just can't draw. That's why my middle is a little bit weird. A skewed curve is skewed like this, or like this, okay? This is a skewed curve. If you remember, the average, the mean, for this distribution was 3.56, so mu equals 3.56. But the median is 3. And you can see that the mode, you can see right here that the most frequent that we've got is 3. So you can see the mode equals 3. All right. In a symmetrical, sometimes called a bell-shaped distribution, when this is symmetrical, the mean, median, and mode are the same. In our distribution, if you look, you'll see that the mean, 3.56, is higher than the median and the mode. What's going on is that these scores up here, 6s and 7s and these 11s especially, they're pulling the average, they're pulling it in the positive direction. This is a positive skew. So what you see here, this distribution of scores for menudo, this distribution of how long of tenure, this is positively skewed. These positive, the higher numbers, the more positive numbers are pulling it. The positive numbers are skewing it in a higher direction. What is it that it's skewing? The mean, right? This 3.56 is being pulled up away from the median and mode. It's being pulled up by these higher scores, specifically these 11s and these higher scores up here. They're pulling it up. This is a positively skewed distribution. One way you can see that is the way that the tail points, the longer tail points, that's going to be positive. So this one right here is symmetrical. Sometimes called bell-shaped. This one is positive, positively skewed. This one is negatively skewed, meaning there's some lower scores that are pulling the average, the mean, down in a negative direction. In a symmetrical distribution, there is no skew. There's no skew at all. What we see here is a positive skew because the positive scores are pulling it in a positive direction, pulling the mean in a positive direction. You should be able to look at a distribution like this and say, oh, I know that the mean is going to be higher than the median and mode because it's positively skewed, right? The mean is pulling it up. Okay. Let's go ahead and also talk about modes. Modes. Remember that we could see what the mode was in this distribution. We can see that 3 is the mode. Well, how can we tell that 3 is the mode? Well, because it's the highest frequency. It's got the biggest peak, right? This is the mode. Now, whether there is one mode or two modes, that's when we're saying unimodal or bimodal. In this case, this is unimodal. Now, normally some people would say, oh, well, you got this other bump over here. But really, let's think about it in terms of how many modes we've got going on in the distribution. There's clearly one big peak over here, which means there's one mode, unimodal. Bimodal looks like that. That would be a bimodal distribution. Now, this bimodal distribution is also symmetrical, by the way, because the modes are equal on both sides. Okay, it's a symmetrical bimodal distribution. This, what we have here, is unimodal, and it is positively skewed. So the menudo one is positively skewed and is unimodal. It's only got one mode, unimodal. All right, let's test ourselves out here. Let's try this out. See if we can do this now with the other data that we were looking at. Oh, before I do that, I forgot. I got to ask you a question. All right, let's look at something else. So here's some data that I've got about first names. So I noticed that there's a lot of differences in the first names. So this is menudo. This is still a menudo stuff. So what you've got here is the charted amount of people whose first names start with these letters. So let me say that again. Let me say that one more time. In fact, we'll even show you the axis title so that you can see it. This down here, these are first names start with this letter. Okay? The first names start with this letter. So the number of people whose first names start with this letter. This right here is going to be frequency. It's going to hate me. Hold on. Okay, frequency. So you can see right here that the letter R is the most common letter that people's first names start with. Okay, there's 12 people whose name starts with R. All right. So here's my question for you. Does central tendency apply in this distribution? No, it doesn't. Does it make sense to get a mean of first names that start with this letter? Would I be asking for what? The mean is J? Is that what I'm asking? That doesn't even make any sense. That doesn't make any sense because these data are categorical. They're categorical data. If I wanted to move around the O or the R or the X, the only reason why these are in any order at all is because of alphabetical order, but these are just categories. This is a bar chart. This is not even a histogram because these data are categorical data. You can't run a mean on these because it doesn't make sense to run a mean on these. Any mean that you would run would be garbage because these are categorical data. I could move the orders around and it would be okay. So for example, let's just put J, let's put J at the end. Why not, right? We can do whatever we want. We can do whatever we want because there's no reason why these got to be in alphabetical order. No reason at all. It doesn't have to be in alphabetical order. We'll just shift these up right here, okay? And then we'll redo this graph. Let's do this again. We'll do it all over again. Here's the new graph. Look, I put J on the end. Ooh, is that wrong? It might look weird to you because it's not in alphabetical order, but it doesn't matter. Well, what does that mean? That means that we're not worried about being symmetrical, okay? There's no center to worry about, right? You say, well, yeah, there's a center right there, but we can move these around. So R could be in the center, or R could be the first one. A could be in the center, or A could be the last one. It doesn't matter because these are categorical. Running an average doesn't make any sense on here. Running a median doesn't make any sense on here. The only thing that really makes sense is to talk about frequency. R is the most frequent, right? R has the highest frequency. There are 12 people whose first name starts with R. That's the only kind of data that makes sense here because this is categorical data. Okay, so let's go to the other example that we talked about last time, which is the data that we used in previous chapters. Let's go ahead and look at these data. We'll get to that in just a second. Let's start with the beginning. If you remember, we had the participants, 7 participants, cups of coffee, how many cups of coffee they'd had in a day, their area code, the hours of sleep, and their liking for donuts. All right? So what we're going to do now is I'm going to actually move these over. I am going to get the sum, the mean, median, and mode for each one of these and see if it makes sense. So the sum for each of these is going to be easy to do because I've already got one over here. These are the sums. Now I want you to look at this. This number right here is the sum for cups of coffee. This is the total number of cups of coffee that all 7 people drank in one day. They're 14. All right, makes sense. Then let's go ahead and do the means for each of these, and then we'll worry about median and mode later. This is going to mess up because of the way that I programmed this. Equals this divided by 7. Sum divided by the n, that is going to be the mean. Okay, there it is. Okay, so let's look at this. So the number of cups of coffee, there was total number, the sum was 14. The mean was 2. Makes sense, the average number of cups of coffee. Now let's look right here at the area code. Here's a number I actually calculated the sum of area codes, 2,395. That doesn't make any sense because area codes are just meant to distinguish from each other. The average area code is 342.14. What does that even mean? There is no area code 342.14. It doesn't make any sense at all because area code is categorical. It doesn't make any sense at all to have a sum or a mean or a median or a mode. Mode, I guess, would make a little more sense because it's kind of like frequency. But it doesn't make sense to do those because it is not continuous data. when you have categorical data, you're not going to run a mean. You're not going to worry about the median. We're not going to worry about a sum. It doesn't make any sense. Here are the sum and average, sum and mean for hours of sleep, and the sum and the mean for liking for donuts. All right, those do make sense because each of those are continuous. Cups of coffee, hours of sleep, and liking for donuts are continuous. Area code is categorical. So we're going to leave the area code blank because it does not make sense to do that. Let's look for the median here with cups of coffee. So the lowest is 0. We have 7 people, so we want the fourth one. So 0, 1, 1, 2. 2 is the median. What's the mode? Well, let's take a look here. The mode is we have 2 2s, we have 2 1s, we have 2 4s. What are we supposed to do? Well, if you've got more than one mode, you got more than one mode. You just list them. So 1 is a mode, 2 is a mode, and 4. They're all modes because they're all the most. Okay? We've already done that for this. Let's go ahead and go for liking for donuts. The median score for liking for donuts, the lowest is 2, then 3, then 4. Then the middle is also 4. So 4 is the median. The mode, the most common answer in this case happens to be, I've got 2 4s and I've got 2 9s. So I've got 4 and 9 are both the mode for liking for donuts. Great. Now, okay, let's look at this cups of coffee. Let's look at this cups of coffee. All right. We're going to look at the cups of coffee in histogram form. So here we go. Here's cups of coffee in histogram form. All right. Here's a cup of coffee in histogram form. You'll notice that we actually kind of drop off when we do this. Thank you for telling me I have a low battery. All right. We're dropping off. Okay. That would be the histogram for cups of coffee. Let's go ahead and look at the histogram for, this is for hours of sleep. The histogram for hours of sleep. When we make this one, let's go start down there. Obviously go up and then back down again. Okay, that'd be the curve for hours of sleep. Let's go ahead and look here for the histogram of, this is liking for donuts. Let me go ahead and label it for you. All right, liking for donuts. All right, so for this one, let's go ahead and draw. We would go back down again and back up. Good. So here's a couple questions. Let's look specifically at this histogram right here of liking for donuts. Is liking for donuts unimodal or bimodal? This is bimodal. You can see there's one peak, there's two peak. There's two different modes. The 4 is a mode, the 9 is a mode. That is bimodal. Bimodal. All right. Let's take a look at the histogram for hours of sleep. Hours of sleep, is this unimodal or bimodal? This is unimodal. We have one mode, and that is 8. Okay, one big peak right there. That is unimodal. Unimodal distribution. Is this distribution skewed? And the answer is yes, it is positively skewed. It's being skewed up by these 12-hour sleep people right here. It looks symmetrical until you add these guys on. They're pulling it up. We can see this when we look at the average. Let's take a look at the average of hours of sleep. So the mean and the median are 8. Sorry, the median and the mode are 8, but the mean is 8.57. It's being pulled up by the people who are getting 12 hours of sleep or 10 hours of sleep. They're being pulled up by the extreme scores. There's too much being pulling up, and it's making it more extreme. So this person right here is pulling it up, pulling the average up, skewing positively. We can see that because in this particular case, it's unimodal, and we know that the average, the mean and the median, the median and the mode, median and mode is 8, right? But the mean is slightly above it, okay? The mean, in this case, that would be X bar, is 8.56 or something like that, 8.56. In a unimodal distribution, if the mean is higher than the median and mode, then you've got a positively skewed distribution. In a unimodal, right? That doesn't always work for a bimodal, okay? But for unimodal, that's what's going to happen. If you have a unimodal distribution and the mean is lower than the median and mode, then it would look like this. That would be negatively skewed. Okay, let's go ahead and be done.